Hello, I am Ali Sajedi. I am going to present our research with Dr. Abraham Hindle and Professor Eleni Strulia at University of Alberta. The research is called Crowdsourced Bug Triaging and recently has been published at ICSME conference. As you know, today in big projects, hundreds of developers work together, and in these projects, there are a lot of bug reports arriving every day, like hundreds of bug reports. So these size of bug reports need a lot of effort to be done for assigning the bug reports to different developers. And as you know, inappropriate assignment of bug reports to developers may result in uh, increased cost or long bug fixing times or generally customer dissatisfaction. So the problem is that having a list of capable developers to fix a bug report and having a bug report at hand, we want to sort the developers based on their suitability to the bug report and assign the bug report actually to the first one. So after this brief overview, I will summarize the previous solutions to this problem and introduce our problem and the evaluation we used and conclude at the end. Almost all the previous approaches, they kind of match bugs with the developers and their expertise. The matching can be done and is done actually using one of these three methods uh, by using and considering the textual elements of the bug reports like title and description, by considering the additional fields like component, severity, project, product, ID, and so on, and even by considering the failed execution assignments. And on the other hand, on the developer side, they consider their contributions to the code, like code commits, and the previous bug fixing history, and also the relations between the inappropriate bug assignment and the next appropriate one. As you know, when a bug assignment doesn't work, the bug is assigned to the next developer. So this is the other approach that's used here. But the novelty of our approach is that we are using the Stack Overflow as a new source of expertise for assigning bug reports in GitHub, which is another network. And we are using the Z-score as an expertise metric, which is using a number of answers and questions a user posts in the forum. And in this metric, number of answers is an indication of expertise, and number of questions is an indication of lack of expertise. So that if a developer answers a question in a subject, then he is knowledgeable in that subject, and if his answer is upvoted, then he is more expert in that area, and vice versa. So that if a developer asks a question in a subject, he lacks knowledge in that subject. But here, if his question is upvoted, it means that the the severity of the case can be neglected. So generally, our solution has three steps. First, we identify all the subject matters in a bug report. This is done by considering and checking and matching it with the text with all the Stack Overflow tags and detect those important tags. And then we identify a list of potential assignees by considering the developers who are available in both Stack Overflow and GitHub and are a project member. And finally, we calculate our expertise metric for the specific bug report. Let's consider an example here. In this example, we have 5 questions that are asked by different people, and they are upvoted. Some of them are upvoted, and each question is tagged with one or more tags. And some of the tags are here shown in bold. It means that these tags are the tags that are matched with the bug report in hand. So those bold tags are the ones that are equal for us. Equals 5 7 developers and showing them the color. And we do with the A or AU value for each user and our social subject the score and relate them by A and Q values via different steps as mentioned before. For example, for user Jane, she answered 3 questions, Q1 and got 28 upvotes, Q3 got 10 upvotes, Q5 and got 14 upvotes, and each one for the first one there is one share tag. For the Q3 we have 3 share tags, and for the last one we have 5 share tags with the report in hand. So based on these values we calculate the A score and Q score. And also Q score is calculated by considering the outputs of the questions asked by Jane and the tag, the share tags. So this value is calculated as well, and then the social subject ever that is for this user is calculated. This one for the user will be like based on defined and FC for the rank and with the score. In order to evaluate our method, we used GitHub and Stack Overflow datasets, 4 different datasets of between 2 to 4 millions of users, and the results are shown in this page. So we got 20 projects with the maximum number of shared users between GitHub and Stack Overflow, and we got 7,100 bug reports. And we ran our algorithm and sorted the users, and we captured top 1, top 5, and accuracy and mean average precision, which actually for bug triaging, we need a mean average precision at 1, which is the real assignee, and it's equal to MRR, or mean reciprocal rank of the real assignee. And the results show that, for example, top 5% accuracy, we got 89% accuracy, and it shows that in 89% of the cases, the actual bug assignee was in the first 5 recommendations of our algorithm. And so based on all the metrics, our approach outperforms previous approaches. We also that are studied in the literature. We also implemented different and those methods. And finally, as a threat to validity, I want to mention that one thing, and that's the non-shared users. What about those users? We are neglecting like half of the users. In order to address this issue, we argue that this is just a new novel approach in this discipline, and never has been used before. And for compensation, we can merge this approach with other sources of expertise, like other Q&A networks, Java forums, MSN networks, and other developer networks, wikis, and so on. So this is just the start of a way, and it introduces a new method that can be expanded and addressed easily in the future. To conclude, we introduced a new source of evidence for expertise, and that's Q&A networks, specific Q&A networks like Stack Overflow. And we argue that these are very, very good and valuable sources of evidence because they are peer-reviewed and easily available, and they are curated by the community of users. And we showed that our method outperforms other state-of-the-art methods.